Sorry, I could barely hear that little recording voice. All right, so let's hear. We are now on day 3. So congrats, you all have made it through day 3 so far, or at least to day 3. Day 3 is not over. So who knows what will happen, but I'm sure we'll be fine. So let's hear. We've talked about, already setting up your environment. So just quick show of thumbs, like, are we all set with your conduit environment? Just give me a quick thumbs up if you have. All right, cool. If you haven't, definitely send me a message, whether it's because like you just haven't gotten to it or, you have come across some issues. We do have office hours after the study group. But at worst, like if you can't figure it out, definitely use a Lumina desk that's on, line on Canvas and stuff like that. So you can at least do the practice. I don't want the environment set up completely halt you from you learning your stuff. So that's mostly been like topic 1 was kind of like intro to data science, getting your environment set up, getting Git set up. And then topic 2, if you remember, well, I guess topic 1 also talks a little bit about Python. And then topic 2 was going about your Git and GitHub and Bash and stuff like that. Hopefully you get the basics down. The main thing you remember, you need to know for Git really, it's just doing that Git add, Git commit, Git push. And that basically is adding your history on there. We talked about and walked through how to set up like a repo, especially if you're copying a project and starting from there versus like contributing to a project. So we talked about like forking versus like just cloning it and then changing up the remote. And then we, of course, talked more about Python and stuff like that. So what's kind of nice is that from here on, it's going to be a lot more Python based and a lot more coding, which makes me happy because that's the kind of stuff that you're going to be doing a whole lot. And so, yeah, we'll get right into it. Sound pretty good? Awesome. All right. So like I mentioned, we're going to talk about Python. I'm going to share my screen in one moment here. But we're going to talk about Python. And we'll see, like, technically we are on topic 3, but I might start bleeding into topic 4 a little bit into here. So just kind of know is that, like, if you have been following along, I just realized I'm sharing my whole desktop, right? You all can see yourselves. Yeah, I'll move you guys off the side. So good. All right. So we have been talking about Python and stuff like this. We might talk about a little bit of libraries. We'll see if we have time. But we're just going to kind of continue forward. So we've been already doing like the data science basics. If you've been kind of following along in that repo, that's what this is cloned of. We did the data science intro and all that stuff. Oops, actually, I'm wrong. We didn't do data science basics. We were doing, where is it? Coding basics. There we go. So we're doing some Python. We were mostly focusing on this core functions, right? Or the core Python things. And then core Python, I call it core. It's not like a technical term or anything like that. We basically showed the data types. We showed lists. We showed strings. We showed what's it called? Dictionaries. So lists and dictionaries are going to basically be kind of like our starting off point for a lot of data things. And then we talked a little bit about for loops, which we'll see a lot in an if statement. And then I talked about while loops too, and saying, while loops, like we'll probably use a lot more for loops than we do for while loops and stuff like that. Okay, so we got the real, I call like the real basics of Python. You can actually write a little bit of code and stuff like that. This next part now, you can kind of see in coding basics, is I have this functions. So this functions, like I will say is like technically, like in code, you could get away with not writing functions. I'm pretty sure you can mathematically prove like you don't need functions, but man, they are super useful. So I'm sure we are familiar with the concept of functions, I think from the bootcamp prep, right? Cool. So I won't take too much time on here, but there might be a couple of things that you might have learned or might not have learned, or you might have learned and just it's been a while or like kind of rusty on it. So it's kind of useful to go through this stuff. But functions are super useful basically for us to like repeat the same procedures over and over. So some people might call this like routines and stuff like that. Functions is just usually what we call it in programming languages. You'll also hear this word called methods. Who's heard the word methods before, right? Like, yeah. So know that methods and functions they're not exactly the same, but they're basically the same thing. They're describing similar things. Methods are usually when we saw like when we get a string, when we get that string and then the dot and then did something to it like dot upper, that would be technically called a method. But it works like a function as well. Basically, it does some kind of procedure that you tell it to. So a couple of things to kind of notes for functions is that in Python, we first write def, D-E-F, like defining that function, and then we give it a name, right? And note that names also follow the same conventions as variable names. So you can name a function and a variable name that has like the same like requirements. You can't start it with a number. We do prefer snake case. Also note that we tend to do functions in all lowercase as well. There are some cases where we might do uppercase and stuff like this, like at least from the like title case, but that's going to be reserved for functions that we'll talk about that maybe in the future, but more like for object-oriented programming. So for the most part, you'll write your function as lowercase, okay? And so this is a function without any parameters. And a parameter is just something we pass into the function and say, hey, you're going to use this, whatever this variable, this value inside this function. So in here, you can see I have no parameters and I just have define my func, right? And you can see here, we define it with this parentheses and then a colon, a equals 1, b equals 2, return a plus b. So basically this will say, okay, return 1 plus 2. So this should always return 3. Okay, makes sense. I think pretty basic stuff. And you can see my print function here. You can see I can also do some stuff where I can say total equals my func. So now that should also be 3, right? So total equals 3. Print total. So note that I'm actually calling another function within this function. So in this case, we'll actually print out something, and then it will return total, which was 3, plus 100. So this would return 103. Okay, there's slightly different stuff here. But just to show you my func first, you should see that C equals my func. And note that if I have C here on the very last line of a cell, Jupyter Notebook is just going to print out the value of that last variable. Okay, so you could see 3 here. Okay, makes sense? Cool. All right. So if I have my print func now, okay, my print func is getting a little more complicated stuff. First, it's going to run this guy right here. So I get 3. Then I'm going to print out 3, and I'm specifically printing it out on here. So it'll actually print out 3, and then it's going to return a value. So I'm actually going to comment this out first. So what you'll see here, because it'll just say C equals my print func, right? That will just save the value 103 in C, but won't print it out. But since this statement right here is actually within the function, this will print out 3. So we'll actually see 3 as the output. Okay, makes sense. But if I actually have it print out what C was, it's still going to print out 3, but C has the value of 103. So I can actually look at 103 and you'll see it actually outputs 103. Okay, so note that reason why I point this out is that print is not the same thing as return. Return is saying, all right, when the function's done, give whatever is like, for example, we call this an assignment. If the variable is assigned to the value of the function, this is the value of that function. This right here, this print total, is just doing things inside the function. It's not returning a value. Does that make sense? Okay, cool. I see nods. All right. So I just wanted to point that out because that is different from this. Sometimes people very early on will confuse these two and thinking that print actually does it because they have the C part. And people think that's like, oh, that's what's going on, but it's not. So one thing I point here is avoid global variables. This is definitely a preference. I've seen plenty of people, including data scientists, use global variables. In Python in general, it's considered bad practice because you can have something called side effects where you don't realize something's changed and it's not encapsulated within this function itself. So what I mean by this is I have C equals 10 out here, and I have my bad func, D equals C plus 1. Now, if I did something like this, C equals 10, right? My bad function, C plus 1. So this should end up being 11, right? Because I changed C, right? And then do my bad func, it'll return 11, right? The problem with this is that if I had a bunch of code, like imagine just like a bunch of stuff in between here, and now like, I scroll over more. I'm trying to prove a point. There is like, you see this part right here, and you're like, what the heck is C? Like C is not from the function anymore. And you might forget what C was. And maybe at first you thought C, like you set C to 10 and you want this function to always put out 11, but maybe later on you change this to like 14, right? And now you're expecting this to be 11. And I run this again, and you're like, whoa, I got 15. You're like, wait, how did that happen? And now you got to chase down like, where did C come from? Where did C change things? Again, oh, there it is. So there's a better way to do this. And the better way is basically passing this C value, since it's used within the function, as a parameter. And that way you say, hey, explicitly say, hey, use this value of C. Don't just use whatever's out there. Okay. Does that make sense of what I'm trying to get at? Okay, cool. All right, I will show you, like, I've debated about showing students this because I don't like people using it, but you'll see this code out there. You'll see global, like, I don't know, F or something like that. And what this does, this basically makes F exist outside of the function, which is all a bunch of like bad stuff. Like, I mean, you can technically make it work and stuff like this, but this is considered, like, by most people, it's considered bad practice. In a lot of programming languages, this is kind of like a useful and like expected like use case of it is something called pointers. But in Python, it usually just makes things more obscure. It makes things less like certain, like, well, what is F defined somewhere else? I need to go search it down. And so in general, you would like to avoid this, even though it is valid Python. So something I just wanted to point out. Okay. And I'm not even going to show you guys how to use it because it's not important enough for us to use. If you are curious, you can look it up. All right, cool. All right, so let's talk about functions with parameters. So like I said, you can actually pass in a parameter. It's kind of like a variable, but it's only for that function, right? So this myvar is a parameter. And if you try referencing myvar outside of the function, I'll get an error. Basically, it doesn't exist. So in this case, I have myvar, whatever that value is. I'm actually going to say myvar is equal to float myvar. So whatever this value was originally, it converts into a float, saves it into myvar. I could use a different variable name, but I like to recycle my variables and be, you know, conscientious of variable usage. So I'm just saying myvar equals whatever this is, but it's a float now. Oops. And then adding 10 to it. And then I'm just returning this string form, which is my number was myvar. Okay. In this case, it should be is now. But you can see now if I run this code, and let's say func of 27, right? That should just return 37. There you go. And you can notice that's a float now because it's got the decimal point in there. Okay, makes sense? Cool. Note that if I now try to print my var, this won't work, right? Because my var doesn't actually exist. Like, it only exists in that function. So if I do this, you actually say, hey, I don't know, my name my var is not defined. And that's because it's only defined in here. Okay. Make sense? Cool. Again, this is where I'll say, like, if you're bad, I'll show you how to be bad. How's that? And then, because I just want to show you guys why I'm saying this is so dangerous. If I do this, put this global. Oh, good. I actually disabled it. Ha, good. Never mind. I'm not going to show you guys that. So good. All right. So the next thing you can do here, this is like a, ooh, like this right here. This like makes my heart flutter. Like, this is an amazing function right here. I know I wrote it myself, but like, it just, like, if I saw something like this from anyone, I'm like, you know what you're doing. So there's a whole bunch of things you can do to kind of like help your function, because it's a reproducible part of your code and it's going to do the same, like, not the same stuff, but it's doing a similar routine over and over again. There's a few things you can do to help this situation. So one is you can have multiple parameters, right? So I can have my var, but I can have multiple my var, comma, my other var, comma, you know, whatever, many different variables, parameters. And here I actually have 1, 2, 3 parameters, but you notice this guy right here, this equals, and this equals none, right? So have we seen this before? I'm just kind of curious if anyone's have seen this before. Okay, I see a couple nods. I see a few like kind of squinting, like, is that new? And that's okay. So what's happening here is that if I were to call this function, okay, and I kind of ignore this, like, I don't know what this is, and I basically put in 3 numbers to add together, or I should say 3 values in here, the function will just work as if I replace each my number, my other number, and convert to string into whatever I passed it in. But if, for example, I either forgot to or just didn't put in a value for these parts, these are basically treated as default values. So basically saying like, hey, if you didn't put in a value for the parameter other number, set it equal to 0. Did you put a value for convert to string parameter? No, then keep it as none. Okay, so that's kind of the idea of what these called our default values. Now, note that Python relies that you can only define these default values towards the end of your function parameter list. So you can't have, for example, other number equals 0, but this be nothing like this. Python won't like that. Python will yell at you. Okay. Python's pretty like chill, but in some cases, Python's like, hey, whoa, I don't know what you're trying to do here. There's a few reasons why, but like the main thing to just know is that if you do have default parameters, like this one and then convert to string, they have to be all towards the end. They can't be in the middle of your parameter list. Make sense? Okay. So that's the first step. Okay. This guy right here, and I'm sure some people have already started reading this already. This right here is a docstring. And basically is that after you first define like your name of your function and the parameter list and everything like that, you can actually create a little string here. And note that, I'll talk about this in a second, why there's 3 quotes. But if you have this string is basically extra documentation that can be actually called up when you call this function later on. So you might write these functions and then later on to like you start using them, you know, especially like in other cells, you're like what did this function do again? That you can actually pull up information that you wrote here. So this is called a docstring. Okay. Question? I think it's no. Okay. So one thing to note right here, you'll see that I have 3 quotes. Has anyone seen this before? The 3 quotes? Okay, see some nods, see some handshakes. That's okay. So note that I can define a string. So like I'll just call it S like this, right? And then I'll just print out S. See that? But if I were to do something like multi-line, like this, Python doesn't like that. Python wants your strings all in one like line. So what I can do is I can actually put in 3 quotes. And sorry, Jupyter's too smart. It tries to fill in for me. And that allows me to have multiple strings, which basically allows me, oops, I put one more quote. There we go. I actually have multiple strings here. And there's the new line character. That's because it's just the way Jupyter Notebook prints this out. So you can see here, it basically prints out this multiple line. And note that you can use single quotes or double quotes. So usually I'll use single quotes because I just like the look of single quotes better. So if I do something like 1, 2, 3, and then of course Python or Jupyter Notebook is too smart for me. So it tries to fill that in for me. I can have multiple lines. Okay. So that's what that 3 quote means. And there's no, I end it with another 3 quotes. Okay. Make sense? Cool. All right. So, all right. Going through this rest of the function, you can see this bunch of other stuff and returns things. Note that I have little comments in here too. So add the numbers together, which might not, to be honest, like this comment might be a little like unnecessary, but I will say to you all, like for clearness, is the more, I would prefer more comments than less comments. Like if you put no comments in your code, I would not like that as much as having too many comments in your code. So you shouldn't like feel like you have to put a comment every line, but it won't really hurt. It'll just kind of like just be a lot of comments in there. So just know that basically I'm kind of saying add the numbers together and then check if the number should be converted to a string format. So note that I'm not saying, you know, like if this is true, then you do this thing. I'm just saying basically what this block of code is doing, right? This block of coding is saying, hey, if convert string, so if this is true, you know, the added, whatever this number added together, convert this into a string, right? Otherwise, it won't convert into a string. So that's basically what's going on here. Okay, cool. All right, so you can actually see this function in place. So I'll kind of show you a little bit how the default parameters work as well. So let's say I do add together. If I do add together, and I'm just going to put all the parameters specifically. So I'm going to say my number is 1, my second number is 10, and convert to string. I don't want it to convert to string, so I'm just going to put false. Okay, and you can see this will just return a number, right? In this case, it'll be 11. Okay, so kind of nice. If I didn't put false here, right, and I said put true, it would convert it to my number was 11. Oops. Oh, I had a little typo. Look at that. Pass Victor, what are you doing? See that? Okay, there we go. So there you can see that it says my number is 11. Now, if I keep this blank, I can just do 1 and 10 because there's already a default value right here. Does that make sense? So the default value is none. And what is the truthy value of none? Does anyone remember?
False.
I see some people mouthing it, but it's muted.
False.
False? Yeah. All right. Yeah, and that's right. None is false, right? So this should be, say, just give me 11. There you go. Okay, so you can see that default value. If I get rid of this guy too, it's just going to be 1 plus 0, right? So that should give me 1. Okay. Now, let's say I want to I can also explicitly say my number equals 1, other number
I think someone had a
equals 10.
question.
And that would work too. And Python's smart enough to say, hey, the other number, my number, my number.
His mic
Let's
is
go ahead and run
broken.
that. And you can see 11. And it's just using the default value.
Victor's
converts
mic
there.
is broken.
Note that if I made like a typo, for example, I did like
Sound.
other, this will get angry at me. It says, hey, oops, hey, that won't work, right? Because it doesn't know what that value is. So you have to put in the exact phrasing here. Okay, cool. And I see Sam R raised the hand. I see some other people going through too. So I saw Sam R first, I think.
Oh, somebody else had a question. I was just trying to get your attention.
All right, I don't know if I can hear you all very well. Did you guys hear Sam R say something?
Yes.
Oh shoot, that's not me.
Right.
My headphones ring. Hold on, everyone. Oh, there's chats too. Wow, I'm really bad here. Sorry, everyone. Let me figure out what is going on with my. I'm gonna stop sharing for a second because it's easier for me to debug here. Oh, I see what's going on, I think. Okay, can someone say something right now?
Testing.
Yes, I can hear you. Okay, good. Sorry, everyone. I had it on the wrong. I had it on headphones that didn't exist, so I couldn't hear anyone. All right. Sorry if I've been. I just realized I haven't been able to hear you all. I see the chat saying that. Okay. So Sam R, and then I know there's some other questions too. So
No, I was good. I was just trying to get your attention.
thank you. No, that's great. Thank you for doing that. I'm just talking to myself. I'm like, oh, whatever. I'm just gonna keep going. Anyone else have any question then?
Yeah, it just seems, I mean, I know you did it to give us an example. Why would you put in my number equals and other number equals? Is there a case where you would? Or?
Yeah, that's a good point. So one case is that if you notice here, I have like, let's say 1 and 10, right? Let's say I have a lot of parameters, and some functions have a lot of parameters, like literally like 20, 30 parameters. It might be helpful to actually say, well, I don't remember what order it is, but I know what I want this value to be.
Oh, okay.
So, and what's nice about that, note that like, in this case, it doesn't matter too much because 1 plus 10 and 10 plus 1 are the same thing. But this is always going to be my number, right? Is the first one.
Right. So you're saying it's ordered there, and in a huge list, as long as you just call it, it doesn't matter where you put it.
Exactly. So if you do my other number and then my number right here. Okay. And the other reason, so that's one reason. The other reason might be like, hey, I want to use the default value of 0, but I do want to convert it to a string. I might actually say, okay, well, I'm going to put in, let's say 1 here, but I want to use convert to string. So I'll say true. Well, if you notice this, that's going to default to other number, right? And it's like, oh, that's not what I want. So you can actually say, well, let me just put this here. And now what's going to happen is going to say 1 is my number, and there's this other number. Oh, that's the default value. And then convert to string, that's going to be true. So we'll do 1 plus 0 and then convert to a string. Okay. Thank you for calling that out. Yeah, there's a few reasons why, and there's other more advanced stuff you can do too, but you'll see this very commonly, and this is actually the documentation when we look up different functions that other people have written, and I say other people like packages and stuff like this. You'll see the notation look like this, and you'll know what that's referencing and what you can do with it. Okay, cool. Any other questions? I think I saw a hand. Yeah. Simone?
So if you don't say, let's say in the second parameter, other number is equal to 0, you don't say like, just put the other number only, and then
Go ahead.
And then when you call the function, you don't put anything for that.
So could you give me an example that you're trying to like?
Yeah, for example, in your actual function, you don't mention that the other number is equal to 0. You just, your second parameter is just the other number, right?
Right. So you're saying like,
take that is equal to 0 out, maybe.
I think what you're saying is like, this is defaulting to 0, right? And so I don't have to call it.
No. I mean, like, you don't default that when you build the function, but then when you call the function, let's say if you don't put any parameter for the second one,
like that.
yeah.
Mm-hmm.
I mean, but then in your function, you don't if you don't have it defaulted 0, like you just have a,
Oh, so like just get rid of this guy. Like
yeah,
that.
yeah,
So like what would happen here, right?
right.
Yeah, good question. So let's go try that out. So there's only one default value, which I am calling it over here, but I don't have that second one. So note that I don't have a value there. And so Python, well, you'll see, will give you an error, is that it basically says, hey, it's missing one required positional argument, meaning that's like, hey, you're missing an argument that you need to have here because it doesn't know what to do with other number. Okay,
Yeah.
that makes sense. Cool. This is for the record, like, this is where if you're from other programming languages, there's something called overloading a function. This is kind of the equivalent to overloading. You can't overload a Python function the same way you would overload other, like, like other functions, stuff like this. You have to be explicit. And so that kind of allows you to get around this. And that's, the more the computer science background. If you have no clue what I'm talking about, don't worry about it because it doesn't matter unless you look into other programming languages. Cool. But yeah, that's kind of the idea. And you'll see this sometimes a lot where you're like missing something and you have to make sure you put in the right one. Okay. Cool. Any other questions? These are all really great points. All right, cool. So these are functions. Oh, I didn't show you the coolest thing. Like what, like, all right, Victor, you wrote this whole thing called a docstring and stuff like that. Like what was the point of that, right? Which, this is usually what people say, like I don't want to write a docstring. If I do help, remember this help function right here, I can actually call help on this function. And look at that. It tells me what the function is, the parameters right here. See, I gave good names here. And then it actually shows my docstring. So you can actually see like what I need to do and stuff like this. And so note that I can do the same thing for other functions like print. You can see it has a very similar kind of idea. It's a little more complicated function, but you can see this is actually the docstring of the print function that's built into Python. And this is really useful when you have like other packages, other code that you might not be familiar with as Python, and you want to look at the documentation, and you don't want to go Google it. You can just pull it up directly right here. Note that also Jupyter Notebook has a function with this question mark. If I do something like print like this will actually bring up the docstring right here. So you can say docstring and actually brings up what's going on here. And note that I can do that with my own function as well. So I can do like add together. Oops. Yeah, there we go. And you can see there's my docstring. Okay. So again, is this necessary? No, but it's a good habit to get in the habit of doing because then it documents your code and you can look at it later on. All right. Sound pretty good? Any other questions? Cool. All right. I'll move on then to the scary lambda function. All right. So this is where I think where people go like, all right, functions, I think I get that. And then they see this thing. They're like, what? Like, what is going on right here? So basically just know lambda functions are like really like shortcut functions. They're still functions. They just create them like kind of in this very one line kind of like declaration. And they're called, sometimes people talk about like one line functions or nameless functions. They're actually called like anonymous functions. Basically, it's a function without a name. Okay. And so right here, I created a function that you normally would see called like my lambda. And here you can see it just multiplies it by 3, right? Okay. So I can call my lambda like normal, right? My lambda, because that's just the name of my function, and call it like 10, and it should be 30. Okay. Simple enough. This is the same thing. This basically says like, hey, this is a keyword in Python called lambda, and basically says, hey, you're going to take in a value, right, of one parameter, and we're going to call it x. Then the colon right here says, okay, with that parameter, do x times 3. It's going to return this. So if I actually take this out real quick, I don't know if anyone's ever tried this out. If you don't pass anything on a function, don't put any parentheses, you can actually see that it's actually a function, right? Function, that's the type itself, main, my lambda. If I run this guy, you'll notice that it's also a function. Okay. So that's kind of what's going on here. And note that it's just a special one called lambda. So basically saying like, oh, it's a nameless function, doesn't have a name, versus this one actually has a name. Okay. So what you can do this. Like, well, one thing you could do is say my named function, you can actually give it a name so you can do something with it now. So you can say lambda, this named function is equal to lambda, the first parameter, so whatever parameter you give it in, and then multiply it by multiply it by 3. Okay, does that make sense so far? Okay, and then I can do my named function here, which will basically just say, oh, this is x. It was like x equals 2. 2 times 3 is 6. So you should see 6 like this. And you're like, all right, like, does that make sense to everyone? What just went on there? Okay. Now, what you probably should say is like, why? Like, why would I do this? Like, this seems so much more complicated than just like, this seems nice and readable. What's going on here? And the answer is, yeah, you probably will never do this. This is not like a really good thing to do, like at least in this form. But there are certain situations, I might have mentioned this last time, is that you can actually use lambda where one of the parameters in your function is looking for a function. And so instead of creating a function and then passing in the parameter like this, you can actually just write out what the function is supposed to do right there in the middle of declaring the function. Because it might be just like a one-time use function. Like, I just need to do this one quick thing, and you can pass it in. And it turns out things like pandas is actually, we do that quite a lot, where we say, hey, basically apply this function, like how do I say this? You will have a function that takes in data, and then it will also do something to the data. That's kind of what the function does. And so you have in the function, its parameters are data and a function to do something to the data with. That makes sense. So you would actually pass in a function as one of the parameters. And sometimes you just need to say, oh, I just needed to basically just get the first letter. Well, I just want the first letter. It's like, well, I can just write a quick function. I don't have to write this whole long thing right here, which doesn't seem very long, but you can imagine writing the function outside of the declaration and then calling it over makes it one level removed. And so it's easier to just kind of quickly change that one part of the function. Okay. Does that make sense to people? I'm not showing you the exact way this is happening, but hopefully that makes sense. Eric.
Is there a scenario?
Can
you hear me? Hello? Can anybody hear me?
Oh my goodness, what's
Yeah,
what's going on with my
we
setup?
can hear you.
Eric. Yeah, it's just Victor.
I can't hear you either. Okay, hold on. Let me stop my sharing. Sorry, everyone. Can try saying something again. Oh, no, I don't hear anything. No, my headphones aren't dying. I see Brian saying stuff on chat. That's really weird. Hold on, everyone. I'm so sorry. Zoom has been fighting me all today, and apparently... Let me try something real quick. Okay, I can hear that. I don't know if you guys can hear that at all. Probably not. I can hear that. All right, can someone try saying something one more time?
Hello?
Yeah. Hello?
Okay, I can hear you on the Zoom's killing me today. All right, everything was set up. My headphones aren't dying. I don't know. I'm so sorry, everyone. All right, Eric.
Yes.
Okay, I can hear you. Good.
Okay, so my question is there a scenario where you would make a lambda function and not assign it to a variable, and how would you use it in that case?
Yeah, so I'll tell you what, I'll create this really quick function. I'll call it like define, let's say do something. And I'm gonna say like do something to this variable x and then something function. So then I'm just gonna do print this, oops. This is x. And then I'm going to return something func x. Okay. So what this will do basically, it's like I created this function that basically will do something with x. So let's say I have a function called def multiply 2, mult2. I'll call it something else so it's not confusing. And then just return y times 2, oops, times 2. All right, so then I have this function here, right? So then I can do something and then say I have like 10, and then that something's going to be molt2. So what that's going to do is basically say, all right, it's going to replace this my something function with molt2 times by 2. And if I look at that now, it says this is 10, and then does the thing to this guy right here. Okay. So one thing I might do is like, well, what if I do something like float? This can actually convert it to a float now. So now I can say, oh, like this is now, like if you remember what float does, right? I don't know if everyone remembers that, but if you do float 10, that converts it to a float. This is a function right here, right? I could also do like print. So this is a function now. And I can also create my own function, but let's say I was on the fly, say, okay, I just want to do lambda x of x minus 10. Okay. And so basically I could create a function like, oh, I don't want to do it by minus 10. I want to do it plus 10. And I can do it much quicker. And I don't have to go back to here, run this function, and then run this guy over here, because this might be separated extra part. And I can see directly what this is doing. Does that make sense? Like where this scenario might make more sense. Okay, I see nod from Eric, so cool. All right. I know this seems very abstract right now because I'm like making up stuff, but trust me that we'll see this a lot more. If you're already in section 4 or topic 4, you might want to look at pandas, and pandas is dot apply. Dot apply basically will take in a function and apply it across everywhere. And sometimes it makes sense just to write a quick lambda function. Okay, cool. Good question. Any other follow-up questions or clarification? Pretty good. Cool.
Yeah, I had put a question in
Yeah.
the chat box.
Oh yeah.
There seemed to be a little bit of disagreement. So like, would x plus equal sign 1, would that be the same thing as lambda x colon x plus 1?
Yeah, good. So that would be like x plus 1 like this. Yeah, be the same idea.
Oh.
Yeah, of course, this is actually like a full, like just like full statement. This is basically just creating a function that will just add 1 to it, right?
Okay.
So, yeah, but you can also do things like, for the record, let's say we have like a list of like 10, 11, right? You can do things like grab the last one in the list. So now I'll always grab the last thing in the list there. So you can do a lot of really funky things with lambda and stuff like this. But yeah, you're right in the saying that it will perform the same action. It's technically different, right? Because if I wrote just lambda x plus 1, it won't do anything by itself. You have to apply that function onto something. Okay, cool. All right, sound good? How are we feeling? Thumbs up, sideways, thumbs down?
When you use like lambda functions, I guess like when you're commenting your code, like do they just, because I know like using like random variables aren't usually like favored according to all of our previous talks with everything. We would still use x because it's like very convenient, right? And the whole purpose of lambda is for convenience, right?
Yeah, lambda is like kind of the exceptions, like just a really quick, like short function. And hopefully the context makes sense here where we can put x and all that stuff. I didn't mention this, which I should have done, is you can also have, you can have 2 variables or 2 parameters in here. So you can actually have x, y like this. And let's just do x times y. And then I got to change this up a little bit. Let's just put like 10 here. So you can actually have a lambda function that takes on 2 parameters as well. And usually you'll see people do xy, xyz, you know. If this function gets more complicated where you have to really put down like the name of it, then it might make more sense to say, okay, let me just write a function like I normally would and pass that in. But if it's a very quick thing, like I would say 2 parameters, something you can write in a very quick line, like that's actually really useful. Like if you find yourself going like too much out of the norm and you're trying to put in a lambda function, reevaluate and say, maybe it makes more sense to make a full function itself. Yeah, cool. Great. Thanks for pointing that out. All right. So that was functions. I believe that is actually a little bit later on, but I know it's referenced in Macbeth, which I know someone had already pointed that out to me in the solution for Macbeth. So then you can kind of see a little bit like what this lambda function, like why this lambda, or what this function is actually doing, all that stuff. Or maybe I'm wrong. Maybe it's not in Macbeth. I was wrong. So anyway, you'll see it in the future. Okay, so that was coding basics like with Python. There's a lot more you can do with Python. I didn't show you everything that possibly can be in Python, but that's okay. We're not going to do everything at once. You'll find it as you go through, and you'll be practicing a whole lot. The rest of like topic 3 is going to be kind of touching on different aspects of Python control flow. There is then talking about other things like statistics and stuff like that. So we will talk about more of the statistics, like finding like the mean. Let's see, I'm trying to remember what's just like, I'm trying to remember. Oh, wait, I don't have to remember. We can look at it. All right, topic 3. So control flow, which we talked about, built-in methods, while loops, nested loops. We kind of talked about loops, like for loops within for loops, right? Creating functions with arguments, user input. We didn't really talk about that. And then I actually think lambda functions is actually the next part, but I thought I'd bring it up now. So there's some other stuff like mathematical notation, central tendency. We'll hit that again, but make sure you kind of do that as you come through, because as you guys might guess, statistics is kind of important in data science. And then of course covariance and correlation. So I'm gonna kind of skip into topic 4. We have about 15 minutes, but I just want to show you a little bit like what libraries are. Now, technically they show you this in topic 1 when they talk about like, visualization, histograms and some other stuff. But I wanted to kind of introduce you all to like the concept of a library instead of waiting until Friday. But just know, this is what I kind of expect you all to kind of read through for Friday's study group, which basically is just talking about the 2 packages called NumPy and Pandas. And I believe, there's a few extra things too. Basically, you're going to do a whole lot of stuff with Pandas, and note that Pandas is going to be a package that you're going to be using a whole lot. Okay.